Question 2, 2021, paper November, it doesn't matter, it's 2021, paper 2A, Slavic chemistry. So, alkenes react with bromine. Name and outline the mechanism for reaction of this with bromine. The naming the mechanism part is going to be very, very simple. The outlining of the mechanism is going to be very, very difficult, especially in this case because it's not your average kind of mechanism question. Like, there's multiple types of ways they could ask you on the mechanism. Draw the curly arrows with the lone pair of electrons, or they give you an actual molecule. But in this case, we're working with a cyclic structure, cyclohexene with Br2. But the same thing's going to happen. We've got the bromine, partially positive. We've got the bromine, partially negative. And all that's going to happen is going to go from here, from double bond to the bromine, transfers electrons to this one. And now what you form is this, where this is bonded with this cyclohexene, so you've got a Br here, and now here it's going to be a positive charge, and this Br with a partially negative sign is going to have Br with a lone pair of electrons, and it's going to bond to here. Now if we can get a bromine here, you can have a bromine here, but it only wants, you don't need to show the final step of that. So from here to the Br, middle Br bond breaks, we have a Br positive charge, one pair of electron, Br minus bonds to it. And I think for mechanisms, knowing how to do it with cyclic structures is imperative as well. It's just an extra step knowing where the curly arrow goes from in the cyclic structure, but that's why they're going to ask these type of questions, because many students would probably struggle, including myself. And then 2.2, explain was attraction between this carbon-carbon double bond and Br2. 3 marks. Okay, so why there is an attraction? Well, we know that carbon-carbon double bond is an area of high electron density. What does that mean? It's electron rich, got a lot of electrons, okay? And the Br, what happens to that? It becomes polarized, and we know partially positive Br is attracted to carbon-carbon double bond. And this type of question is a very weird type of question. It could be applied to anything really, depending on a double bond between something and something, an attraction, and it could be electrophilic addition. As you know, yeah, you could reuse it, that's what I'm trying to say. So it's really important to know the key points they really want. So Br become polarized, C double bond is an area of high electron density, aka it's electron rich, and the partial positive and Br becomes attracted to the carbon-carbon double bond. And then 2.3, draw the skeletal formula of the halogen alkane form on butyl-1,3-diene. This reacts with an excess of Br2. I don't like these questions at all, and it wants a skeletal formula. But if we CH2, CH2, what's going to happen? Well, how many carbons we're working with? 1, 2, 3, 4 carbons. And what's going to happen is that because of an excess of Br2, these are going to be replaced with a Br, the hydrogen. So it's going to be something like 1 carbon, 2 carbon, 3 carbon, 4 carbons, right? It's butane, methane, ethane, propane, butane, and each of these ends is just going to have a Br at it, at the end of it. Br, BR, and I only drew out these circles to show you guys the carbon, but you're not supposed to do it. So it should just look something like that without the circles. But that's what would happen. A pretty tricky one marker, but to be honest, this is just how well you know mechanism, so that's a nice 5 marks. And obviously how to do it with the cyclic hexene. This one, I guess you could get 2, 3, and then this one, a pretty tricky one. And that is the end of question 2.